Okay, here we are at section 3.4. 3.4 talks about kind of the graphs of what exponentials look like. So if our f of x is 5 to the x power, hang on just 1 second, if our f of x is 5 to the x power, boom, f of x equals 5 to the x power, well, if I'm looking at essentially what we've always been looked at, f of x equals c times a to the x power, some starting amount, times a base to the x power. Our unwritten c here is 1, so we're always starting with 0 comma 1 because our starting amount is 1, unwritten 1. It's an exponential function because our variable is in the exponent. The base is 5 here. In this case, the base is just 5. So f of 2 means f of 2 equals 1 times 5 squared. So that would be 25. 1 times 5 squared is 25, done. F of 0 equals 1 times 5 to the 0 power. 5 to the 0 power is 1 times 1 is 1. F of negative 2, well, essentially that's f of negative 2 equals 5 to the negative 2 power, or 1 over 5 squared, or 1 over 25. Because remember, if we've got a negative exponent, we make that negative exponent positive when the base and the exponent move to the other side of that divided by bar. So there's our 1 over f of negative 2 is 1 over 5 squared, or 1 over 25. So that's essentially just some of the basics. If we take a look at what a graph looks like, because we're going to graph this as well, f of x equals 4x. One of these is f of x equals 4 to the x power. One of these is f of x is 4 to the negative x power. Well, let's see. If this is f of x equals c to the c times a to the x power, we remember that from earlier sections, if a was greater than 1 here in question A, our a, growth factor a, is 4, and that's greater than 1. Therefore, this has to be growth, so this one has to be growth. 2a has to be growth. This one shows growth because every time we move forward 1, we're multiplying by something to make us bigger. If we move forward 1, we're multiplying by something bigger, and sure enough, we're moving from 4 to 16, it looks like. So this, sure enough, looks like a. There's our a, and this one matches to graph 2. If we take a look at 4 to the negative x power, I'm going to kind of rewrite that. I'm going to say maybe 4 to the negative x power equals, let's see, 4 to the negative 1 times x power. And I separate those for a reason, because then we can have 4 to the negative 1 power all to the x power. And we're kind of going backwards this way, because usually we go from 4 to the negative 1 power to the x power. When we've got parentheses, we multiply exponents to get here. But we're kind of moving backwards to kind of separate and conquer, because we're used to having our variable out here just as x, not as negative x. So we can change it to x by pulling that negative 1 in here, and then 4 to the negative 1 power is 1 over 4 to the x power equals 0.25 to the x power. 0.25 is certainly less than 1, so therefore this green one is decay, and therefore decay is right down here. This is decay. Every time we move forward, we're multiplying by a number that's smaller than 1, and we're getting smaller. So this one is decay, because a is less than 1, and we have, therefore, this is situation B, and B is situation or graph number 1. So there's two different ways to kind of look at 4 to the x power and 4 to the negative x power. And in general, exponential functions have this shape, f of x equals c times a to the x power, where a is greater than 1 and a can't be equal to 1 because, or sorry, a is greater than 0 and a can't be equal to 1. If a were equal to 1, then we'd just have basically a flat line. And they do have, exponential functions do have the following properties. Domain is the set of all real numbers. Essentially, all numbers can go into our x can be x value, or the x value can be any real number, because x over here does not cause us to divide by 0, does not cause us to take the negative or square root of a negative number, so therefore all real numbers come into the party. And the range is all positive real numbers, because our asymptote is right down here. There's our asymptote. We'll approach that line, but never touch it. We'll approach that line. Here's our asymptote over here. We'll never touch it. We'll approach it, but never touch it. So there's our horizontal asymptote at y equals 0, essentially the x-axis. And we've got one of the following shapes. Either we've got growth when a is greater than 1, or r is greater than 0. And over here we've got decay. Decay because a is less than 1. Every time we move forward, we're multiplying by something that's smaller than 1 to get us smaller, and therefore r is less than 0 also, because they're all related. A and r are related. So essentially there's our graphs of what exponentials look like.